Hey everyone, and welcome back to Knowledge on Ears. And in today's video, we are going to be exploring what humidity and temperature sensors are. So obviously, they measure the humidity and temperature in the environment. So over here, we're putting a humidity and temperature sensor up against a fan. And this, as you can see in the serial monitor of my Arduino program, is decreasing the temperature. And for the humidity part, basically, if you just put the sensor underwater or something, you would start to see the humidity increase a lot, obviously, because there's more moisture and there's water everywhere. So now, we are going to dive straight into how the humidity and temperature parts of this sensor work. So right here, we have a temperature humidity sensor. This one specifically is the DHT11 sensor, but there are many out there. There's ones like DHT12 and DHT22, and they're all they work very similarly, but they can be a little bit different. Some of them have 4 pins, some of them don't even have a board, but they all work pretty much the same. And so, how do you calculate the temperature on this sensor? Well, let's dive in. So basically, the temperature is calculated using a thermistor, which is basically a thermal resistor. So it's a resistor that finds its resistance depending on the temperature around it. So there's 2 different types of thermistors. There's NTC and PTC thermistors. And the difference between the two is based on the correlation between both temperature and resistance. So NTC stands for negative temperature coefficient, where what it means is that as resistance increases, temperature decreases, and vice versa. So they're inversely proportional. And for PTC, positive temperature coefficient, they're just directly proportional. So temperature increases, so does resistance. So in this case, there's an NTC thermistor inside of here. And what happens if there's a very high temperature, then the resistance decreases in here. And basically, we calculate the resistance by sending a current through it, and we find out what the resistance is using Ohm's law. It's very basic. And then once we find the resistance, we can have some type of graph or some type of chart where we figure out at what resistance, what will the temperature be. So some of the things you can do, you can also use the Steinhart-Hart equation that can also convert the resistance you have into a temperature reading. So that's basically how the temperature part of this sensor works. Now, let's talk about the humidity portion of this temperature humidity sensor. So, there's 3 layers. There's the top electrode, there's the dielectric layer, and there's the bottom electrode. Now, if you notice, this type of setup might look like a capacitor to you. That's because it is. So this type of specific sensor is a capacitive humidity sensor. And there's many other types out there. You can find resistive humidity sensors and so on. So in this case, this actually is built off of a capacitor because in this sensor, we are using capacitance to figure out the humidity, and we'll get into that. So we have 2 electrodes here, the top and bottom. What do? Well, just like in a capacitor, they are conductive and they carry charge in between them. So in between the 2 electrodes, there's the dielectric layer. And basically, dielectric means it does not conduct electricity. And also, this layer is what absorbs water, so it's very absorbent. So it absorbs the moisture in the air, the humidity. So what happens is that air has a very low dielectric constant. And dielectric constant refers to the ability to hold charge, so the ability to have a high capacitance. So air has a very low dielectric constant, but water, on the other hand, has a very high dielectric constant, which means it has a higher capacitance. So when there's only air in this dielectric layer, there's a very low capacitance in between these 2 electrodes. But let's say it's very moist and there's a lot of humidity. Then more water is absorbed into this dielectric layer, which in turn creates more capacitance. So that's how this whole thing works. More humidity, capacitance increases, and then we can convert this capacitance into a relative humidity percentage using math. It's like the same thing like the temperature. There's a graph. We can figure out how the capacitance converts into humidity. But what's relative humidity? Basically, it's humidity relative to the temperature because air with higher temperature can carry more humidity than air with lower temperature. So relative humidity just talks about the humidity relative to the temperature there. So that's how humidity and temperature sensors work, and we went over both humidity and temperature. I hope this makes sense. Thank you so much for listening. Bye!